Chapter 6, Lesson 1 of Geometry, and in this lesson and video we want to look at using coordinate methods to help us classify these quadrilaterals. Now when we're classifying these quadrilaterals, we looked at opposite sides being parallel, so we've been talking a lot about parallel lines, and then when we were talking about parallelograms specifically, we were talking about the lengths of sides being equal, all lengths being equals in that rhombus, and we looked at angles being right angles when we're looking at a rectangle. So what we want to look at in this lesson is using some algebra skills that we've learned in the past to help us determine whether these lines are parallel or whether they are perpendicular, meaning they're forming right angles, or whether they're the same length. So what I want to do quickly is to review some of those things that we've learned before. In algebra, you learned when you were working with lines how to figure out the slope of a line. And you take the two coordinates of a point of points that are on the line, and you put that ratio of the difference in the y coordinates over the difference in the x coordinates. And in doing so, you determined the slope of that particular line. So once we know the slope of the line, then we can start talking about parallel and perpendicular. Hopefully you remember that when you're looking at parallel lines, if lines are parallel, they're never going to intersect. It should make sense to us that the slope of those lines, the rate of increase, the ratio between the vertical change and the horizontal change remains the same. So in parallel lines, the slope will be the same. In perpendicular lines, the lines that come together and form right angles like this, well, what's the relationship between the slope of this line and the slope of this line? Well, the relationship is that they're negative reciprocals of each other. Negative means that they're opposite in sign, so one of the slopes will be positive and one of the slopes will be negative, and then they're reciprocals of each other, meaning that one is the, you take the ratio and you flip it over. So if the slope of a line is a half, the perpendicular line will have a negative sign, so it'll be negative, and it will be the reciprocal of 1/2, which would be 2 over 1 or 2. Another way to look at it is that if you multiply the two perpendicular slopes together, you'd get a slope of -1. Now, talking about perpendicular lines as far as horizontal and vertical lines, those slopes are not negative reciprocals of each other because the horizontal slope is 0, but the vertical slope is undefined. And so they're not negative reciprocals of each other, but there is a theorem that says that all horizontal lines are perpendicular to all vertical lines. So if you get a slope of 0 and then a slope that's undefined, you're talking about a horizontal and a vertical line. Those will be perpendicular as well. And then when we were talking about the rhombus, we talked about all the sides being the same length. And earlier this year, we worked with the distance formula, and that would give us the length of a segment. And we remember that the distance formula says if I take the two x coordinates and subtract them and then square it, plus the two y coordinates, subtract and square it, and take the square root, that's going to give me the lengths. So what we're going to be doing then in these next few examples is using these two calculations, the slope and the distance formula, and then looking at those to classify the quadrilaterals. Because if we're talking about quadrilaterals, what was that second question we asked? How many sides or pairs of opposite sides are parallel? So you're going to need to calculate the slope and then of the opposite sides and see if they are the same. If they're the same, they're parallel. If they're not, then they're not parallel. And then when we looked at rectangles, we need to know, do we have right angles? Well, then again, we're going to look at slope because we need to know if they're perpendicular. And then in a rhombus, we need to know if the sides are congruent, so we're going to need to use the distance formula for that. So we're going to be using these formulas from before in order to help us do that. Okay, so that's kind of a summary of what we're going to be doing, and so hopefully you remember that. If not, we can review some of that some more. I'm going to wrap the video up there, and what I'm going to do is in the next video I'll do a number of examples where we try to determine or classify the quadrilateral using these, so you can watch as many of those examples as you need to help you finish off the homework in this lesson and to do the problems. But it's going to really come down, or a summary would be this page right here, so you really need to know what's on this, this slide right here.